Hello everyone, and welcome back to the restoration series on this Ward's Airline radio from 1952. Last time we took a look at this thing, we cleaned it up and we rebuilt the whole chassis, and we got it to a point where it was able to turn on and receive some stations, but it was very weak. So the goal for this part is to get the radio working fully and then do an alignment on it. So let's get started. So in part one, we got this thing all cleaned up. I went ahead and rebuilt the chassis, replaced all the capacitors and resistors, but there's still one issue that we need to solve, and that is for the 12AU6 tube. Pin 1 is supposed to have -2 volts, but I'm only getting -0.3 volts, and that's after replacing all of the components underneath. And I went through and checked voltages on all of the other tubes and all of the other pins on this tube, and they all look to be absolutely fine. So what I'm thinking is that the 12AU6 tube might be a little bit weak, and that's why this radio is only receiving stations very weakly if I'm outside with it. So I went ahead and I bought a couple packs of new old stock 12AU6 tubes. So I'm going to be trying one of those out, and we'll see if it wakes the radio up. So I'll go ahead and I'll pull out the 12AU6 tube that is in this radio. And I had mentioned in the first part of this video that the little metal structure inside the tube is a little bit oxidized. And I don't know if that would have any effect on how the tube operates, but I didn't really like seeing that, so maybe that's an indication that the tube is failing. I'm not sure. But we'll go ahead and we'll replace it with this tube. You can see this one is not oxidized on its structure. This tube is made by Admiral. So let's see if this wakes up the radio. So with the radio plugged in and the new 12AU6 tube installed, let's see how it performs this time. Tube filaments are glowing, so that means the 12AU6 filament is not open. Well, it seems like the 12AU6 was not the issue. I can still hear squealing sounds coming from the oscillator. But yeah, that changed absolutely nothing. So the 12AU6 must not be the problem. I'm going to try out another one and we'll just see if it changes anything. All right, now I have a General Electric 12AU6 installed. Let's see how that sounds. Exactly the same. So the 12AU6 is not the problem. I'm going to go ahead and check the tube voltage and see if it is still the same. Well, you know what? It's better. Now we're getting -0.7 volts. So I think I'm going to try, just for the heck of it, the other 12AU6s I have, and we'll see how much the voltage changes. So I put the Admiral tube back in, and it is getting -0.6 volts. So it seems like different 12AU6 tubes have different characteristics on that pin. This one is getting -0.9 volts, so it's getting half of what it should be. There should be -2 volts on that pin. And the fourth and final tube that I have is measuring -0.8 volts. So clearly the problem is not the 12AU6 because it sounds exactly the same on each of those tubes. So our problem is elsewhere. So I put the original 12AU6 back in, and I think it's weak because it is measuring -0.2 volts. So I think I'm going to replace it with the 12AU6 that performed the best, and then we'll keep working at this thing to see what the problem actually is. So what I'm going to do now, and what I probably should have done earlier, is I'm going to check the resistance of the antenna and the coil that is underneath the chassis, because if the antenna is bad, then that would absolutely be causing the problems we are seeing. So let's see what the resistance is. So according to the SAMs, the loop antenna, the primary, should measure 2 ohms. 2.2 ohms, that looks great. Let's just see what it is between here and here. 1.8 ohms. So the resistance on the loop antenna seems perfect, so that's good. So on these 2 points, I'm measuring the secondary of the oscillator coil, and the schematic calls for 7.2 ohms, and we're getting 7.6. So that is working perfectly fine. And this here's the coupling winding for the coil. The schematic says 2.4 ohms, and that's measuring 2.5. That's perfect. And the primary looks good as well. The schematic calls for 0.8 ohms, and it's measuring 1.2. So we know that this oscillator coil is working perfectly fine. It's not open or shorted, and everything is within spec. Which is good, because if either the loop antenna or the oscillator coil were bad, I'd be in a little bit of hot water, because I'd have to find another one of these radios to steal the coil or the loop antenna from. So I'm glad to see that those are still fine. So now what I want to do is measure the resistance of the 2 coils that are inside the little metal can here. And at the end of part 1, I said that there weren't any capacitors inside it, but there actually are, and they must be little silver micas, because it shows the capacitors on the schematic. Their values aren't marked, but when I took this can apart, all that was inside it was just the coils and some metal terminals that were making some connections on a little piece that kind of looked like a little PCB inside there. So that must be what we're dealing with in there. So I'm going to measure this. So both the primary and the secondary should measure 29 ohms. That measures shorted. All right, so I think I might have figured something out here. So I'm using my vacuum tube voltmeter to measure this, because the battery in my digital one died and you're not going to be able to see it. And so what the schematic calls for is both the primary and the secondary should be measuring 29 ohms. I'm on the secondary right now, and it is measuring just under 30 ohms. But if I go ahead and move over to the primary side, oh, what? Okay, I swear it was not working just a second ago. They were both measuring completely shorted just a minute ago. Now they're both measuring 29 ohms, just under the 30 mark on my meter. It's measuring completely fine. So I think the capacitors inside this thing are okay, because the primary is measuring good. I'll measure the secondary one more time. And yep, it is completely fine. So the coils inside this little can here are functioning just fine, and it seems like the capacitors are as well. And one thing I'm doing here real quick is I am measuring the resistance of the volume potentiometer as I move it, and I am getting a nice gradual resistance change on my VTVM as I'm rotating the pot. The needle is going down and back up. So the pot is working just fine. So with all of that tested, really the only candidates for a problem are one of these 2 tubes, because I'm pretty sure that the 35Z5 GT is fine, because this handles the voltage regulation, and I've been checking voltages all throughout this thing, and they all seem to be perfect. So I don't think this is bad. I could be wrong, but I think it is either the 50C5 or the 12AV6 that is causing our issue. And I did end up buying a couple new old stock 12AV6s and a 50C5 to swap them out so I can test that. And I happen to have a new old stock RCA 50C5 tube in the package here that just arrived. So I'm going to go ahead and swap out this 50C5, put in this RCA one, and see if that tube is the problem. So there's our RCA 50C5 tube. So I'll go ahead and get that installed. So let's see if that fixed it. And that is a resounding no. So the problem was not the 50C5. You hear the popping and the crackling that this thing is doing? It's been doing that the whole time, and so I thought in the beginning that it was maybe some sort of leaky capacitor or noisy capacitor that was doing that, but I've replaced all the capacitors in this thing, and so I'm thinking that maybe something inside the 12AU6 tube is not quite making a connection, because it seems like if I wiggle the 12AU6 around, it'll kind of accentuate that noise. It's hard to say. That's the 50C5. I don't know. But I do have some 12AV6s coming in a few days, so I'll be able to swap this tube out and see if the 12AV6 is the problem. And if it's not, then I'm going to have to be doing some troubleshooting because I don't really know what else it could be at this point. All right, Editor Max is going to chip in here for a second. So it was at this point that I made a little bit of a mistake in my research and trying to figure out what was wrong with this radio. So what I ended up doing here is I took out the original 12AV6 tube and I measured the two diodes inside it with my multimeter, and it said that they were both open. And so I thought, well, there we go. There's the problem. The 12AV6 tube is bad. Well, after receiving my two new old stock 12AV6 tubes that I ordered and doing the same test again, the meter also said that the diodes were open in those tubes as well. And I was thinking, that can't be right. Well, little did I know that you can only measure those diodes when the tube is conducting. And that makes sense because this isn't a solid state application. So I ended up putting that new old stock 12AV6 into the radio and turned it on, and it made zero difference. So the problem is not the 12AV6 tube. And so after doing that, I turned my attention back to the IF transformer can, and I wanted to take a better look at that little mica layer that was inside it. All right, after doing a little more research and taking some measurements inside the radio, I have officially found the problem. So after thinking about what this radio was doing, how it was making those crackling and popping noises even when you left it alone, the first thought I had in my mind is, what if the two little capacitors inside this IF transformer have silver mica disease? And so what I did is I flipped the radio over, and so inside this IF transformer can is a little square wafer, only a little thicker than a piece of paper, that has two mica capacitors inside it. And so what happens over time is those mica capacitors can start to degrade, they can start to carbon track and turn dark, and they can end up leaking and even shorting across the primary and secondary of the IF transformer can. And that happens with a lot of these old radios now. So at this point, we know that the problem in this radio is not caused by any of the tubes. So that leaves only one more thing it could possibly be. I've gone ahead and opened up the IF transformer can. There's a little clamp that goes on the bottom of it that you have to remove, and then you can go ahead and carefully pull the metal shield of the can off. And so that leaves you with this. You can see the two separate coil windings for the IF adjustments. And right here is our little mica wafer. And you see how it's gotten dark around where the metal terminals are? That's a telltale sign that that mica wafer is degrading and we are having silver mica disease symptoms. And so how this works is these four metal tabs are making connections across that mica wafer. They're just resting against it. But when the mica wafer starts to degrade, then it can short or arc across those connections. And so what we need to do is take that mica wafer out of circuit. So there's two ways you can go about doing that. The first is to physically remove the mica wafer from underneath those terminals, but that's kind of invasive because you can see the little tiny wires going from those coils to those terminals there. I don't really want to disturb those or break them, so what I'm just going to do is the less invasive route. I'm just going to cut off these metal tabs, those four corner tabs. That way it won't be making a connection across that wafer. And then what we'll go ahead and do is I'll install two 100 picofarad mica capacitors on the underside of the can. and then that will make the connection between this point and this point on both sides. And that should fix our silver mica disease problem. And even though I'm leaving the wafer inside the can, it will no longer be connected, and so it's not going to pose any hazards. So I'll go ahead and do that, and I'll show you what it looks like when I'm finished. So I've gone ahead and I've cut off those 4 metal tabs inside the IF transformer, and I've installed 2 100 picofarad mica capacitors across the primary and secondaries of both the coils. So these 2 capacitors are replacing that little mica wafer that I disconnected from circuit. And so that should be our silver mica disease problem fixed. Let's go ahead and turn this radio back on and see if it finally works now. Okay. It's different. I hear a station in there. It's very faint, but I can hear it. Okay, so that did change things. So we obviously had a problem inside this can with the silver micas. I'm going to go ahead and check the 12AU6 pin 1 voltage again, and we'll see if that's changed. Ooh, look at that. It's closer. We're at negative 1.2 volts now. So what I'm going to do is put one of my better performing new old stock 12AU6s in there and see if we can't get that voltage as close to negative 2 volts as possible. All right, let's see how it sounds now with a new 12AU6 tube. Okay, well, that's different as well. I hear a faint station. And if we check the voltage on this one, we have negative 1.8. So it looks like our negative 2 volt line on this tube is now working. So that is a problem solved. I think negative 1.8 is close enough. But because we still have a radio that's not quite working, I'm going to try putting in a new old stock 12AV6, and then if that doesn't work, I'll put in a new old stock 50C5. I just want to see if any of the tubes are weak, because I don't have a tube tester, and this is the only way I can figure that out. So because when I put the new old stock 12AU6 in and the voltage on that pin went down farther, I think the original 12AU6 was weak. So I'm going to leave the new old stock 12AU6 in. I just went ahead and put in a new 12AV6. Let's see if that makes it stronger. Okay, I hear stations. But it's hard to tell if that made a difference. So what I'm going to do is put the old 12AV6 back in and replace the 50C5, which is the audio output tube, and we'll see if that makes the audio louder. Well, that sounds different. Okay, well that didn't change much, so I went ahead and put all 3 new old stock tubes in those spots. So let's see what that does. Well, if I put my fingers on the antenna, now it's really loud.
Every box here is immediately.
So now it's receiving.
In some areas, like a 62-minute drive time on the north.
Or someone in Birmingham.
And then munitions around the world. And with all that's happening in California, does that...
So that right there, just doing this, makes it perform a whole lot better. So maybe what we need to do is either take this thing outside or hook up an external antenna to it, because I think this thing is working now. Well, I figured out that this thing is indeed working now. If I go ahead and use my little AM transmitter board and hook it up to an iPod, if I go ahead and play the music, you can hear it's working. And I can tune away from it using the tuner. So we know that the band, the tuning capacitor on here, is working. I'll go ahead and shut this thing off so it doesn't keep producing that static, because that's what it's from. So the next thing we need to do is give this thing an alignment. All right, so now we're ready to do the second step of this repair, which is the alignment. So what we need to do is go ahead and take a look at the SAMs and see what we need to do in order to align this radio. So the first thing we need to do is turn the tuning capacitor fully closed and set the pointer parallel to the base of the cabinet. So I went ahead and turned it all the way to the closed end, and I aligned the pointer so that it is close enough to being parallel as possible. The SAMs says use an isolation transformer if available. If not, connect a 0.1 microfarad capacitor in series with low side of signal generator and B-. And I do have this thing plugged in now to a big isolation transformer, so that will help with the alignment. So throughout this alignment, we're going to need some tools. You're going to be using an oscilloscope, a modulated signal generator, and a voltmeter to monitor the output. So the first step in the alignment is to adjust the IF transformer, and that will adjust the 455 kilohertz peak. So in order to do that, I need to set my signal generator to output 455 kilohertz. And so I'm going to use my oscilloscope to get it as dialed in as possible. And I'm going to temporarily turn modulation off, because if I have it turned on, you can see it makes the scope kind of freak out a little bit, because this is an older scope. So I'm going to shut that off so I can get a nice waveform on that. And I'm going to turn this until we get down to 455. And according to the signal generator, that should be right there. And we're pretty close. I think I might hook up to my more modern scope, because this one, when it shows the frequency of something attached to it, it kind of fluctuates a lot. Like the lowest I saw was 441, and now it said 457. And so I'm going to hook it up to here. Okay, this one seems better. It says we're at 450, right at the low end of 451. So I'm going to turn this just a little higher. Okay, so that is 455, so I'll go ahead and take that out of the picture. Okay, so now we are ready to do the first step. So we need to hook up the signal generator. The high side of it, so that's the positive, is going to go to the stator of rear section of tuning gang. So that is the part of the tuning capacitor that is still. You see how one of the sets of blades doesn't move when I turn this? And this is the rear side, so we need to hook up to that. And the low side is going to hook up to B-, so that's the ground. But it also says we need to use a 0.05 microfarad capacitor as a dummy antenna. And so here's a 0.05, well in this case it's a 0.047 capacitor right here. So we'll go ahead and hook this up to the positive. And what we'll do is we're going to hook it up to the external antenna jack on the back. And so that is our positive side connected. Now we'll go ahead and hook up the negative to B-, so that is any spot on this radio that is ground. Just gonna make sure that's not gonna touch anything else, and it isn't. So that is our signal generator connected. I'm gonna go ahead and put this back down. So with that connected, I've gone ahead and I've turned on my modulation on my signal generator, so that way it produces a tone that we can hear. But we also need to hook up the output meter. So I'm gonna go ahead and hook that up. And it says we need to hook up the output meter terminals across the voice coil. So that is going to be the 2 wires going to the speaker right there. Okay, so that is the output meter connected. So what we'll do now is it says the radio pointer needs to be near the center of the dial. So I'm gonna go ahead and turn the volume up and put this near the center. That's the tone coming from the signal generator. So you can hear as I'm turning the tuning knob, you can hear that my signal generator tone is coming through in multiple places. So we just need to set this to a place where you can't hear it. So I'm gonna set it to right there. And so those are all the connections we need to make for step 1. So now we make our adjustments. So we need to turn the coil adjustment on the top of the can, and then there's another one on the underside of the can. So I'm gonna adjust the trimmer inside the can, and we should be able to see something on the meter as we do that. So I'm gonna go ahead and adjust the top adjustment in the can, and let's see what happens when I do. Wow, look how off that was. I'll turn the volume down a little bit. So you can see we're passing the peak. So I'm gonna align it to where this is at its highest point. So right there. So that is our adjustment for the top one. That is really loud, holy crap. This is gonna be interesting because I'm gonna have to turn this in such a way that works. So you're not really going to be able to see what I'm doing right now, but I'm going to adjust the other adjustment inside the can from below. Wow, that's so off. Wow, that is so off. I turned the volume down just so we don't have to listen to that. So right there, turn that down. So that second IF adjustment, that was way off. So I wouldn't be surprised if by the end of this alignment, this radio will be a whole lot more sensitive. And so with that, that is step 1 of the alignment complete. So now we're ready to begin step 2, which is the 1620 adjustment. So I've gone ahead and set my signal generator up for 1620 kilohertz. And so what we need to do is adjust the screw on this section of the tuning capacitor until we get maximum output on the voltmeter. And so the screw's right here, so I'm gonna go ahead and adjust that and we'll see what we get out of the meter. I'm not hearing anything out of my signal generator, and its volume is all the way up. Why is it doing that? What? Yeah, I'm not sure why we're getting that. Yeah, I'm not really sure why we're not getting anything. It should be very straightforward. Oh, I hear it now. What the heck? I can hear it now. It's just really quiet. So I think I'm gonna align this. Oh, there we go. Huh. Wonder what was going on there. Okay, that's a very touchy adjustment. So let me put my earplugs back in, since now I actually have a tone out of the radio. All right, that's good enough. That is good enough for me. So that is how you align the 1620 kilocycle adjustment. So now we are at the third and final step of the alignment, which is to do the 1400 kilohertz adjustment. And this step's a little bit different. Instead of connecting the signal generator directly to the radio through a capacitor, we have to couple it in through the antenna. And to do that, it says to fashion a loop of several turns of wire and radiate signal into loop of receiver. Okay, I imagine that should be enough turns. So we'll go ahead and hook the positive end up to this. Turn my modulation on. It says I have to turn the dial to where there is maximum output. Ooh, wow. So that's how you couple a signal into the antenna. So maximum output is right there. So let's go ahead and adjust the 1400 kilohertz adjustment. And so that is going to be right here with this screw. So it looks like the peak is right there. And this adjustment's kind of weird because when you unscrew it on the meter, it kind of just tapers off. It doesn't go up and then back down. So I unscrewed it to the point where the meter stopped going up. So that should be aligned. So now that is all of the steps completed for the alignment of this radio. What I'm gonna go ahead and do real quick is go through that whole process again off camera, because when you align the radio, you might have to go back and do the adjustments again, because aligning one thing might throw off the other a little bit. So I'm gonna go ahead and just go through it one more time, and then we will see how this radio performs. Well, I've made more discoveries since doing the alignment. Between that point and now, I went out and bought myself a tube tester, because if I'm gonna be working on tube radios, I might as well have a reliable way to test the tubes. So I've been going through and testing each of the tubes that were in this radio, and I found out that the 35Z5 GT, you know, the tube that I've been ignoring all this time, well, it has severe leakage inside it. It's either gassy or leaking, because if I test the quality, which is the regular emissions, it's perfect. But if I test for leakage, the needle goes way up here, which is severe leakage. The 35Z5 doesn't have a grid, but it does show significant leakage. And so I put in a new one, because this tube tester came with over 100 tubes, which is amazing, and 99% of them have been good so far. And so I grabbed one of the 35Z5 GTs that was a part of it, put it in the tester, and it was perfect. Great emissions, no leakage. And so that tube is this one, and so it's being powered up right now. And I also went ahead and replaced the 12AV6 and 12AU6 with my new old stock tubes that I already had, because both of those tubes measured a little bit tired. They were still good, but the new old stock tubes were a lot more good. So I put those in. The original 50C5 audio output was perfect, so I left that tube in. And so now this radio is as good as I can possibly make it. I'll tell you right now that it's still pretty lackluster in terms of sensitivity, because I think this radio is what you would call a city radio. It wasn't really meant to pick up distant stations unless you hooked up an external antenna, because it does say an outside antenna is generally required. And so even with the radio aligned now, it still has a lot of trouble picking up stations. And I'm pretty sure it's an antenna related issue, because if I use my AM radio transmitter, it works great. I have it hooked up to an iPod Nano, and this is hilarious. You can use these as FM radios. And so if I transmit FM radio into this thing, I can get FM stations on an AM radio. So that's a little way if you want to add FM to an AM radio without modifying it. Just use one of these little cheap transmitters and hook up an iPod Nano to it. And so if I hit play, there's an FM radio station. Comes in nice and strong. And if I go ahead and adjust the dial on here, if I put it up a little bit, I can do the same on here, and it picks it up. So The dial tracking on this radio is working fine. And so now this radio is completely restored, replaced all the resistors and capacitors, fixed the silver mica disease, gave it an alignment, put some good tubes in it, and so now this thing should last for many more years to come. So to end this video off, I think I'll let the radio speak for itself. And so that is the restoration of this Ward's Airline tube radio from 1952. This thing was pretty much a basket case. It needed all new resistors, all new capacitors, needed some of its tubes replaced, and it had silver mica disease that we needed to fix. But after an alignment, this radio is now fully working and ready to be used as a radio once again. So, thanks for watching, and I will see you in my next video.